Welcome all of you for the lesson unit number 2, diode and precision rectifier. It's a very interesting and important topic, rectifier. Why do you want to see this unit? What is the application of the rectifier? Where it is using? Is it useful for you? So everyone having the mobile phone, the how it is working with the help of the battery. The battery is there in backside of that every mobile phone. You will going to charge the mobile phone. How do you charge the mobile phone? With help of the adapter. With help of the, you can say about the, it is called adapter. The adapter, okay, it is a adapter. Okay, so does your battery, your mobile phone battery is a AC or DC? My mobile phone battery is a DC power supply. It's a 1.2 volt and 2000 milliampere hours. Okay, 2000 milliampere hours or 3000 milliampere hours. But what is the voltage? 3.2 volt or 3.5 volt my battery. So is it battery is a DC or AC? My battery is a DC. Then how do you going to charge from AC power supply? How do you going to charge from the AC power supply? So with the help of the adapter, what is there? AC to DC conversion, that is called a rectifier. That is called a rectifier. So that is you will going to see in detail about this unit. So I will going to teach to you. So why do you want to study the diode rectifiers? The rectifier is a convert AC to DC for charging my mobile phone. Charging my mobile phone. That's why I am using for that rectifier. Okay, the next one is a precision rectifier. Why do you go for that precision rectifier? Only two topic is there in that mainly heading in that unit. One for the diode rectifier, second one is a precision rectifier. Why do I want to go for the precision rectifier? Diode rectifier, it has that small limitation. It is not suitable for that signaling type of that application. Signal processing type of the application, it is not suitable. Okay, why it is not suitable means it is some voltage drop is a take place. That drop also I want to minimize. I want to go for the precision rectifier. So this is about the introduction of this unit. Let's we go to the content of the unit. It has only 4 content in the unit, only 4. Okay, first one, off wave rectifier. Okay, this is a diode rectifier in that one, off wave single phase off wave rectifier. Second one is a single phase full wave rectifier, topic number 2. Then topic number 3 is a 3 phase full wave rectifier. So with the R load, the only 3 topic and the comparisons. Then fourth topic is a precision rectifier. So only 4 topic, very simplest about okay topic, okay, in that unit, only 4 topic. If I go for that second topic, full wave rectifier means it is a subcategorized, okay, center tap and bridge rectifier. So what is the difference between center tap and bridge rectifier? Both also same waveform. For example, you will go from Kobarkan to Mumbai. Kobarkan to Mumbai, you can go by government transport or you can use for that private transport. So either you can go for that center tap or bridge rectifier. So either you can go for that government transport or private transport, but your destination is common, that is called Mumbai. So that is as both method, it is the destination is common. Okay, that is there. Then it is a why it is using, like you will going to learn about that once. What is the difference? So that is a comparison of the center tap and the bridge rectifier, and the comparison of the what is the off wave rectifier, what is a full wave rectifiers. You will going to learn about the comparisons. So this is a only 4 topic in the unit, very simple to you will going to understand and learn about that ones. So first let's we go for the diode rectifier. Already I told about the why do you go for the rectifier. My adapter, my mobile phone adapter. What is my mobile phone adapter is doing? My battery is a DC power supply. The block government is okay, the electricity board is provided alternating current. The alternating current is there in the block point. Okay, so in that AC power supply is there in the block point, 230 voltage, 50 Hz AC power supply is there, but my mobile phone is a 3.5 volt DC power supply. So it will going to convert AC to DC. Who is going to do a small the charger or the mobile phone charger, you can say, or a mobile phone adapter, you can say, that adapter it will going to do. How it is possible AC to DC converted? That is called okay, rectifier. The AC to DC conversion is called rectifier. So if you have see that one, this is a rectifier, this type of that is called. Then what is there inside the rectifier? Inside the rectifier is either half wave rectifier or full wave rectifier. So what is the difference between half wave and full wave? It is a low efficiency half wave. Full wave is a high efficiency. So you can go for the diode rectifier or controlled rectifier. Okay. So diode is a controlled rectifier? No, diode is a no. It is not a controlled. Diode is not a controlled rectifier. So what is meaning of the controlled rectifier? The device it consists of the gate terminal. The device it consists of the gate terminal. So you can say some example of the device: SCR, MOSFET, IGBT. Okay, so you can say about the triac. Okay, like you can say about these are the devices. It's a control device. So what about the diode? It consists of any gate terminal. So gate terminal means controlling. So any gate terminal, no gate terminal, so it is a uncontrolled device, uncontrolled switch. So it is act as a switch. Switch means what? Switch means on and off. Switch means on and off. Similarly, on and off. When it is on, when it is off. When it is on means when you will going to power is a flow from anode to cathode. How many terminals? Two terminals. What are the two terminals? One is this side anode and this side is a cathode. When power is a flow from anode to cathode means, see the arrow mark. So arrow mark, the current is a flow permitted. It is called the forward bias. It is called a forward bias. Okay, when the current is a flow from this side means, does it will going to permitted? Does arrow mark is allow? No, the arrow mark is not allow. So it is not allow. So during the reverse bias condition, it is a, or it is a, okay, not a reverse bias. Okay, so during the reverse process or a reverse flow of the current, the diode is not permitted. During the reverse flow of the current, the diode is not permitted. So this is about the, so you will going to say about that it is not permitted. So only one direction it is going to permitted. Okay, so it is a permitted only forward direction. So reverse direction it is not permitted. It's a block the reverse direction of the flow of current. So what is the purpose? It will going to, when you will going to transfer from here to here, when it will going to transfer means it will going to convert, okay, rectifier. How? So it is a current is here is there. It is current is a flow. Okay, when it is current is AC current is a flow. When it is coming here, how it is rectified? So that one you will going to learn about that a half wave as well as full wave. How it is a rectifier. Why it is called a rectifier waveform. It's very interesting. You will going to see. It is a switch. The switch is what is the purpose? On and off. Like it is there for that your fan switch on and off. Similarly here also on and off. When it is on, so it is not. Whenever you will going to give the power supply on the here. Whenever you are going to give the power supply here, okay, the circuit is a flows, the current is a flow. So you should be know about, so when the current is a flow, the circuit should be closed. Okay, so I will going to show you how the circuit is closing. Okay, the next one, see that once. So what is here is showing, it is a characteristics diagram is showing. What is the characteristics diagrams? I versus V, VI characteristics. It is called VI characteristics. So what about the VI characteristics? You can see there. So it is start from the 0 and then it is a slowly increase 0.1, 0.2, 0.3, 0.7. So once it is a 0.7, so it is a called it is a up to 0 to 0.7 is a it will go to voltage drop. The diode is not conducted. Does it is conducted at this point? No. The diode is conducted at this point? No. But once it is across the 0.7 volt, diode for permitted to flow the accepted the flow of current. So you can accept it. It will going to accept it. Okay, clear? Okay. So what about the drop of the diode? 0.7 voltage. If it is a silicon diode, 0.7 voltage. Other diode, it will going to increase into the 1 volt and the 1 volt and above. So what about the loss? Conduction losses is occurs in that forward voltage drop conditions. So this is about that the background of the diode. So the diode, it is a uncontrolled device. So the next one, okay, types of the rectifier. Types of the rectifier. What are the types of the rectifiers? Half wave rectifier and a full wave rectifiers. So that is there in the unit. Okay, we will going to detailedly see about what is half wave rectifier and what is a full wave rectifier in so following of the one more video. Okay, come to the review questions. So review questions. First question: does diode is a bidirectional current flow device? No, it is a unidirectional current flow device. It is like the arrow mark. Arrow mark is a like it is look like the arrow mark. It is a unidirectional anode to cathode. Okay. Does gate terminal is there in the diode? Does gate terminal? No, no gate terminal. The diode consists of only two terminal, anode and cathode. So why the gate terminal is not there? If it is gate terminal is there, means it is called a controlled device. Based on the construction, it is not developed with the gate terminal in the diode. Okay. What is the voltage drop of silicon diode? Silicon diode is voltage drop is across anode to cathode. You will going to check with one of the voltmeter the 0.7 voltage drop. Okay. What is rectifier? It convert AC to DC. How to charge the mobile phone? With the help of the rectifier. Okay, you can develop on that one. What is your mobile phone you want? 3.5 voltage. So you will going to use the rectifier that convert, okay, convert AC 230 voltage into that one. You will going to step down into 5 voltage. Okay, for you will going to convert another 10 voltage AC. After that 10 voltage AC is rectified into 10 voltage DC, and 10 voltage DC you will going to filter used to filter out, and followed by you can use 1 voltage regulator. The regulator you can use, okay, so for example 7805 regulator you can use, okay, 5 voltage constant. LM317 you can use to fix the 3.5 voltage. That's all. Thank you. So next class we will going to see about the types of the rectifier.